Good afternoon, everyone. Hope you had a good lunch. You've enjoyed playing the trivia. That's a good way to pass the time. I know Trenton put in a good amount of work. I want to thank him for doing that and entertaining us and teaching us all at the same time. That's good stuff. We hope this afternoon, and we'll do the same thing for you in terms of being able to learn some stuff and be entertaining at the same time. Certainly have what I think is an interesting program. What I'll do, let me click over to the next slide here and show you the things that are on the afternoon agenda. The afternoon is focused on more materials and construction type issues as opposed to the grouping of traffic engineering things we had this morning. Really good stuff there. We'll start with Safety Edge and have what's worked really well for us, I think, combination of VDOT and contractors sharing perspectives and experiences and things. Robbie Good, area construction engineer for the Stanton District, will kick us off, and then Jacob Dodson from Superior Paving will give contractor perspective. Then we'll talk about balanced mix design. Rob Crandall can't get in front of a camera without talking about balanced mix design anymore, it doesn't seem. Used to be TAC, now it's balanced mix design. But it's not what you might expect. We talk a lot about the mix and the testing requirements and things, but one of the things we decided to put on the agenda this year is about how will it affect field operations. I think the good news is not a lot of things go as expected, but Travis Light from Boxley Materials is gonna make a presentation. Boxley got a good bit of experience, not only with pilot sections they've done, but they also worked on the short paving sections on the HVS at Virginia Tech. And so they have a pretty unique perspective about BMD paving. So we'll hear from Travis on that. And then I'll apologize ahead of time, you have to listen to me. It's a repeat presentation from things you've seen at the Mid-Atlantic Expo and Conference on spec changes for 2021. I do go over the hierarchy of contract terms as well. You have to sit through 6 or 7 minutes of that. And then we'll go over just the very few spec changes we have for 2021. And then following me, Harold Caples from the construction division. He's our statewide contract engineer. He'll give a short update on the 2021 paving program and just give an update on contract advertisement, letting, award, summaries in different ways and things that I think everybody will find interesting. And then we'll wrap up with Mike Dudley to give an update on VCAT and training, status of training and training opportunities in the asphalt world. So we've got a good program. Let me remind you all throughout. In fact, we got one early that we're going to answer this afternoon. Please use that Q&A function. If you have questions, you want us to talk about things in the Q&A at the end of the seminar, please use that Q&A and we'll pick them up and try and answer as many as we can. If we run out of time, we'll get answers back to people later, but we will try to address all of them. I think that's good for now. I'll cover some more administrative things as we go through and at the end. But to get us started for the afternoon, going to talk about Safety Edge. As I mentioned, we're going to hear from both a VDOT ace, Robbie Good, and then a contractor with Superior, Jacob Dodson. And we'll start with Robbie. So Robbie, if you'll take it away and start our afternoon.
Hello, my name is Robbie Good. I'm an area construction engineer with VDOT out of the Stanton District. I want to talk about an FHWA Everyday Counts initiative called the Safety Edge from a VDOT field perspective. The objectives are to review the safety edge, what, why, and where, review the initial VDOT IAM and the current special revision for pavement shoulder wedge, and review a few VDOT field observations. Safety edge technology shapes the edge of the pavement at approximately 30 degrees from the pavement cross slope during the paving process. It basically eliminates the vertical drop off and allows errant vehicles a better chance to return to the roadway, especially bicycles and motorcycles. It has minimal effect on cost, and the reduced pavement edge raveling can lead to longer pavement life. But most importantly, it has the potential to reduce injuries and save lives. The chart here on the left is the United States fatalities by FHWA focus area between 2016 and 2018. The green, representing roadway departure only crashes, is 46%. Under the purple, there's a subcategory, intersections and roadway departures, 4.1%. Roadway departures and pedestrian bicycles, 1.4%. Together, these three roadway departure statistics represents over 50% of the fatalities during this period. This is making countermeasures such as a safety edge more important. Another interesting fact is that on rural road crashes involving edge drop-offs, you are 2 to 4 times more likely to have a fatality than other crashes on similar roads. Under this drawing, the two pictures at the top represent your traditional pavement edge, where you have a vertical edge along your pavement. When you place your shoulder material level with the top of your pavement, over time, your shoulder is going to settle or erode, exposing that vertical edge. With the safety edge, the edge of pavement is placed on approximately a 30-degree angle. Over time, as the shoulder stone or shoulder material settles or erodes, it exposes that 30-degree angle, which should allow vehicles to come back up on the roadway a little more easily by reducing the amount of tire scrub the driver is going to experience. This map just gives you an idea about how throughout the U.S. The implementation of the safety wedge is going. On the states with orange, it's considered universally. Maroon, there's a site analysis or systematic. Gray, not at all, or on a case by case. Yellow has no baseline score. The A, the states with the A, have some type of alternative design. So where do we want to use the safety edge? In almost every situation to prevent vertical edge drop-offs, especially along curves, hills, and narrow roadways. It's not needed in areas where your existing shoulder is going to be steeper than your safety edge. You don't need it in curb and gutter, guardrail, driveways, or intersections. But when considering to use it or not, please be consistent and consider its benefits. The initial IM-MD-002 was dated May 1st, 2014, and gave VDOT its early guidance on the usage and implementation of the safety edge. It came with an initial special revision, and over the years that special revision has been updated. The last one dated 9/16/2019 that was in last year's resurfacing contracts. And this special revision under applicability, the contractor shall install shoulder wedge on roadway segments where all the following conditions are met. In open ditch sections, paved shoulder widths 4 feet wide or less, speeds greater than 35, and on specified final asphalt surface lift thicknesses at least 1.25 inches. Some other important specs involves the angle of the safety edge is required to be 30 degrees plus or minus 5 degrees. And the special revision also recommends removing soil buildup and vegetation that exists within 1 foot from the existing edge of pavement. The special revision also has these two details, reviewing wedge over existing pavement. The one on the top left reviews a low shoulder scenario, where you have it on the existing pavement. The break of your safety edge starts before the end of your existing pavement and ends right at the end of your existing pavement. And then you put shoulder material to fill in the low shoulder. On the high shoulder condition, you have to remove the high shoulder. Again, place your safety edge on top of the existing pavement and then put your new shoulder material and grade it to drain. The next set of details in the special revision review wedge over unpaved shoulder. The top left is a low shoulder condition. And in this scenario, the safety edge break is at or just a little bit before the existing pavement edge. The safety edge continues out into the voided area, the low shoulder. So you're actually kind of in dumping a little bit of asphalt material to fill in this low shoulder and create your safety edge. The remaining voids can be backfilled with new shoulder graded material. Under the high shoulder, you're again striking off the high shoulder area to be able to maintain positive drainage. The break point is at or before your existing pavement. It slopes down over the shoulder, and then you place your new shoulder graded material and you grade that for positive drainage. The key in these two scenarios is to place the safety edge to avoid losing lane width by placing the wedge on the unimproved shoulder. Within the special revision, there's no specific pay item for the shoulder wedge itself. It's paid under the cost for the asphalt concrete. There is a pay item for pavement shoulder wedge prep per linear foot, which includes the removal and disposal of surplus, tracked, and spilled material resulting from the contractor's operation. Aggregate-based material used in the shoulder is paid for in accordance with 305 of the spec. Field observation, placement location. In this one, your pavement edges can be very inconsistent, especially along your secondary and rural roads. It's important to follow along the existing edge of pavement. You need to keep this break point at or before your existing edge of pavement. If you get it out onto an unsupported shoulder or unsuitable shoulder, you could possibly end up with this longitudinal crack right at the break point. In addition, if you have existing issues with the edge of your pavement and you try to place the safety wedge on top of that, you're going to continue to have problems with the safety wedge above as well. On your roller technique, first and foremost, your main objective is to get proper density on the mat itself. You may be able to adjust your roller technique to reduce lateral movement and maintain an adequate edge angle. Once you finish rolling, if you're not meeting that 30-degree plus or minus specification, you may have to adjust the angle coming out of the screed in order to end up with an angle after the rolling that meets the special provision. The ability for the mix to be able to maintain this edge is mix dependent, especially depending upon the tenderness of the mix and the size of the aggregate in the mix. One thing is we do not recommend waiting for this edge to cool down a little bit before rolling it. We recommend that you roll the edge right along with the rest of the mat. This one is one that the field staff and the contractor need to have open and honest discussions about, the shoulder preparation. Special revision recommends that you remove 1 foot of the material outside the existing edge of pavement. The details of the special revision show grading as much as 1 to 2 foot outside the existing edge to make room for the shoulder wedge. The key here is to perform the prep as needed to install the edge and maintain drainage, but you need to keep it as minimal as possible. Under the picture on the far right here, you've got a rather large windrow there, and hopefully you don't run into that situation too often. But this material is going to have to be removed in order to maintain positive drainage along the shoulder. The picture here on the left gives you an idea of what happens when you do not adequately remove the existing vegetation. The grass starts to run up through the safety edge and basically cause the safety edge to fail. One of the things that we've noted is that when you mill and overlay, or mill and fill, when you mill, if you mill out a little bit extra width through here, remove this extra shoulder material, then when you come back and do your fill section, your safety wedge can taper down right at the end of your mill section, and that seems to work pretty well when you remove this material during the milling operation. Checking the angle, you want to lay your level across the slope of the pavement and try to come up with these distances A and B. All right, so if you're laying approximately 1.5 inches in depth, and your measurement of A, which is based on the length of your slope, say that's 2.5 inches. If you take the inverse tangent of B over A, or the inverse tangent of 1.5 over 2.5, you know with about 31 degrees, which is within your target of 30 degrees plus or minus 5. Or someone else suggested to me that you download an app on your smartphone that can provide the angle that the smartphone is laying on. Take and place a rag or something on the asphalt to protect your phone, and then lay your phone on top of that rag and the phone will tell you what angle it's laying on, and that'll give you a good idea whether your edge is meeting the specifications. In the end, these two pictures kind of represent what your goals are. The original project was constructed in July of 2003, and these photos were taken about 8 years later in June of 2011. As you can see, the one on the left had the safety edge installed, and you can see how the edge is holding up even in the low shoulder area. The picture on the right is a section without a safety edge, and you can see where the edge is very vertical in the low shoulder area. And if a vehicle runs off here, it seems like it's going to be hard for them to recover and get back on the roadway. All the information that I gathered that's in this presentation came from FHWA's Safety Edge website located at this address. You can also look up and find additional proven safety countermeasures at safety.fhwa.dot.gov/proven countermeasures. I would also like to extend a special thanks to Kathy Satterfield with FHWA's Office of Safety, Greg Schultz, Adams Construction Company, and Scott Altice with RK&K.
All right, thank you, Robbie. Good information. I'm really glad in your presentation you talked about the origin of Safety Edge. Sometimes those of us who deal with it all the time forget that all these acronyms and different things where places where things come from, why and where did they start? So I'm really glad you mentioned that. For those of you who may not know, everyday counts, you'll see EDC as an acronym, is something FHWA started really to share good ideas. You know, somebody somewhere in the country has got a good idea, and every day counts to get that good news shared with everyone else, so that if they want to use it in other places, they can. Well, Safety Edge was in what was the very first round. It was not the only thing, but it was one of the most popular. And I think we're probably in round 6 of everyday counts now. All kinds of different safety initiatives. It's not just asphalt and paving, it's everything in our industry and ways to get better. So they even have a web page if you ever want to go check it out one day. Check out all the ideas on all these rounds of everyday counts. Thank you for mentioning that, Robbie. And we'll just go ahead and pivot now from what you shared to Jacob Dodson from Superior Paving, and hear from Jacob and his experience with Superior Paving placing Safety Edge. So Jacob, take it away.
My name is Jacob Dodson with Superior Paving Corporation, and I'm discussing the pavement safety edge from the contractor's perspective. The application, when to use it, open ditch lines, paved shoulder widths 4 feet wide or less, speed limits greater than 35 miles per hour, and applying an asphalt lint thickness of at least 1.25 inches. The first part of our operation was the shoulder prep. Basically, removing that material and grading the shoulder 1 foot outside the edge of the existing roadway, removing all the vegetation and ensuring positive drainage. One process we use on an overlay only route was to perform the shoulder prep with the use of a motor grader, a wheel loader, and a broom. The grader operator would follow 1 foot off the edge line of the roadway with the blade set to windrow the material back onto the existing surface. The wheel loader then follows the motor grader, picking up that windrow material into a truck and disposing of it. The broom then follows behind the loader, removing minor dust and debris from the roadway to make it safe for traffic and prepare for the asphalt overlay. It's important during this process to be mindful of the angle of the grader blade, matching the profile of the existing road and using minimal down pressure. Second process we used to perform the asphalt shoulder wedge was on a mill and overlay route, actually using a milling machine. Basically, we would mill the entire lane width and then back up and overhang the mill 1 foot outside the edge of pavement and mill that separately, basically hauling all that contaminated material away and disposing of it properly, keeping that out of clean wrap and clean milling piles, ensuring that doesn't get back into the mix and that material is taken care of. Now, the amount of material being removed varied quite a bit from route to route. Some routes there'd be little to no material to be disposed of, and other times there'd be a significant amount. Basically, every route's going to present different circumstances and must be planned and scheduled for. Whether it's the amount of trucks you're using, the crew, the type of operation, it's going to routinely change. The first type of asphalt safety wedge that we want to discuss is the wedge over existing pavement. This process involved placing the asphalt shoulder wedge on the existing pavement only. We found this type of pavement safety wedge performed the best for us with minimal downsides. We were able to keep a more uniform 30-degree slope throughout the pavement project and eliminating negative impacts while rolling. The second type was the wedge over unpaved shoulder. The installation of the shoulder wedge onto the unpaved shoulder worked well on wider roads with 1 foot to 2 foot shoulders and edge line striping. This helped to prevent traffic and trucks from driving on the shoulder wedge and causing damage to newly placed asphalt. We did have challenges on narrow roadways, 20 foot to 22 foot wide. Traffic, loaded trucks maneuvering by the equipment sometimes caused stress and damage to the adjacent newly paved lanes. These occurrences were difficult to avoid, especially if the pilot truck and traffic were passing our equipment in a curve. Traffic, especially large vehicles, used 100% of the road, and consider that extra 3 to 6 inches of safety edge as part of the roadway. Basically, they would use everything that they could to try to get around us and create space without making any kind of contact with the equipment. And sometimes, due to narrow roadways, we would push that traffic out onto that safety wedge, and sometimes it would damage it. But we did have to go back when needed and correct some of those areas and make sure that they were right before we left. But overall, it was successful for sure. The safety edge device came from Willow Design's innovative paving products. The device we chose to use on our plant mix schedule was the Willow Design Safety Edge. This is a unit that comes with a bracket so that the safety edge can easily be removed and switched from one side of the screed to the other. Also, it's electric powered. Any adjustments can be made quickly by remote control. This includes approaching driveways or guardrail sections. The safety edge can temporarily be raised up and lowered back down as needed by the screed operator. One item to note with this device is the use of an electrical cord running along the end gate of the screed and back to the generator on the paver. The screed operator must absolutely pay close attention when moving the gate in and out, ensuring that electrical cord is fastened out of the way and doesn't potentially get pinched and cause damage to that cord. Next, talking about the rolling techniques. Care must be taken with the asphalt mix during the rolling operation to not incidentally increase the degree of the edge and roll the mat back to a vertical face. One technique we thought to help with this issue was to adjust the safety wedge flatter than 30 degrees. This allowed for some stand-up of the mix to occur and helped correct the edge back to that desired 30 degrees once rolled. Also, making a vibratory pass, keeping the front breakdown roller off the edge of the mat approximately 6 to 12 inches, then allowing the second roller to make the necessary passes on the safety edge for compaction. This prevented significant movement of the safety edge and still allowed us to achieve desired compaction and density results, still rolling it within temperature. This was a focus on secondary routes, especially when the safety edge was placed on an unpaved shoulder. Wanted to prevent excessive roll down and cracking and splitting, so we tried to stay off of it when we had to, and try to do whatever we can to minimize any kind of cracking or shoving or movement. Next was the inspection process. I felt like we overall had a really good communication with VDOT and worked with the inspectors well out there on the job site. We absolutely went through the test strip part in the mornings on the first day of every route. We kept the inspector up to date with what was happening throughout the day and continued throughout the entire project. If any issues did come up, we found that the inspectors were willing to work with us. We were willing to adapt and make changes as needed. And it was a good line of communication, and the trust was there that we were trying to do the right things, and that if things did come up, we were able to come to an agreement and try to find ways to improve the situation and to make sure that we were putting down the right kind of product that the inspector was happy with. Next was the shoulder stone and backing material. Once the asphalt's placed, a standard shoulder stone operation with the new edge preventing as fast of erosion. We'll be keeping an eye on these routes in the future. Really interested to see how they do weather over time. And finally, safety is the end goal. The use of the safety edge will better provide opportunity for an errant vehicle to make proper corrections to return to the roadway. As shown, the Federal Highway Administration states, a vertical drop-off of 2.5 inches or greater has been shown to be problematic at speeds of 55 to 60 miles per hour. Drop-offs of up to 5 inches with the safety edge are traversable at these speeds. Driving mistakes can happen. It's important to do our part to mitigate the consequences of those errors. Overall, we felt the safety edge was a solid success and a significant safety improvement to the roadways. We look forward to continuing this process in the future and partnering with VDOT to continue making Virginia roads safer. Thank you.